Hello, welcome to lesson M3 on energy, friction, and efficiency. Now, first of all, instead of the word types here, we're going to use the word stores of energy. And change this to position. Now, the reason why we're doing that is because energy is really just the ability to do work. That is what energy is. Now, there are several ways that we have the ability to do work or cause a change. And similar to that, money has many different types of currency. The value can be stored in various currency. Now, that could be US dollars or euros or Canadian dollars. Money can be stored in different values. Energy is the ability to do work, which can be stored in different ways. Now, the two most common are going to be kinetic and potential energy, and I do encourage you to read the Eureka videos. Three common types of energy, and we say types, common stores of energy, is kinetic energy, which is really just energy due to the motion. So what this is saying is that this object can cause a change due to its motion. If I've got a ball coming towards me at 50 kilometers an hour, it can probably hurt. It can cause a force through some distance upon me. Chemical energy. This is just energy within chemical bonds. Now, a couple of other types of forms of energy or stores of energy that we looked at previously would have been like thermal energy or elastic energy. Now, the other type here is potential energy, which is energy stored due to position in a field. Position in a field. Now, that could be a gravitational field, an electric field, or a magnetic field, but the energy is just stored in there. Now, the textbook, being a little bit outdated, talks about this converted energy and transmitted energy. Converted energy is really just energy moved from one store to another. Same way, if we convert our Canadian dollars to US dollars, we convert energy from, let's say, kinetic energy to potential energy, or from potential energy to kinetic energy. When we talk about transmitted energy, this is not energy that's actually being converted. This is energy moving from one device to another. Now, this could be within the system or between systems. There are four energy pathways, four ways that energy can be transmitted. And again, this is heating, as we talked about last year. This is conduction or convection, radiation in the form of electromagnetic waves, current, which is electrical, and mechanical, which is the one we're going to look at within this unit, mechanical, and this is through some sort of force. Now, when we talked about potential energy as energy stored to position in a field, really in this unit we're only going to be taking a look at gravitational fields. So we call it gravitational potential energy, right? Which is energy stored due to height. So if we've got this ball, two boulders, one sitting this far above the person, one sitting this far above the person, this has more potential than this one. This one can cause more force through more distance, cause more work on the person than this one can. Now, as energy is converted or transmitted, not all of it transfers in the way that we want. And so we have what we call efficiency, which is really just a ratio of how much energy work is transferred in the desired way. Of how much energy, and I'm going to put work here because energy is just the ability to do work. Maybe we want to transmit it in terms of work, right? Is I'm going to say moved to the way we want, right? The desired amount. Like, the energy doesn't go anywhere, it doesn't disappear, but it might not be in a method that we want. So, for example, a light bulb. A light bulb, its main objective is to give off light. Thing is it doesn't just give off light, it also gives off radiation and heat. And so the efficiency that should say efficiency is simply the amount of work output divided by the amount of work input times 100. It's a ratio. But this work output, it should be noted, is desired. That is what is going to affect it. Because if we're using our light bulb to heat something up, it's going to have a different efficiency than if we've got a light bulb that's designed to light something up. And so if we desire light or we desire heat, depends on what work or what energy we're using here. Now, mechanically, there are three ways that we can be increasing efficiency at least, and the first one is to reduce the friction. Right? Usually through the form of some sort of lubricant. The oil in your car reduces friction in the engine. Speaking of cars, properly inflating the tires can also help increase the friction, increase the efficiency. This reduces drag from the tires against the road. Right? And so changing the oil in a car regularly. Manufacturers, usually it's somewhere between 5,000 and 8,000 kilometers. Whatever your vehicle recommends, I suggest that you do it, because changing the oil, that is the lubricant, and that's going to keep it there as opposed to the oil breaking down. So if I've got 150 joules of energy coming into some sort of device, and let's just say a light bulb, and it gives off, let's say, 50 joules of light and 100 joules of heating in the form of conduction and convection. Now, this light bulb, because it's a light bulb, we want light. So using that efficiency formula, only 50 joules are what's considering is coming out, the work output. The other 100 is not what we desired, so it's not a factor in here. Divided by the 150 times 100, this basically is a percentage, and that is going to get you 33% efficient. Okay. Friction usually is considered a negative when it comes to machines, but it can also be considered a positive thing. Rosin to improve grip in gymnastics could be an example of something where you want friction. Curlers avoiding the sweeping. To slow rocks. And another one I'll put there is tires to grip the road. If you've ever been in a car where you're, let's say, on ice and the tires are just spinning, and you're not moving anywhere, it's because there's no friction between the tires and the road. Or if you wind up with ball tires, right, you're not getting nearly as much friction and you wind up not being able to move as much. And so that's a case where friction is definitely a positive, especially during braking. Right? Vehicle braking, I don't mean like breaking down, I mean like braking as in stopping. Again, friction is a very good thing. It won't stop without the friction. So that's lesson M3. Any questions? Let me know. Have a good day, everyone.